Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle. Now, the thing is, this only had, I think, 21 ratings, so I don't know how hard this actually is, but it was considered very hard, so that's interesting. Anyways, the rules aren't here, but I know what the rules are. The rules are normal Sudoku, and it's called, okay, sorry, today's puzzle is called Semi-Symmetry by Lizzie1. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. The other rule that is basically all the digits on the arrow must sum up to the circle that it is attached to. So, for example, these three digits must add up to what this digit is. So an example of this would be like 2, 2, and 4. That would be 8. So these three digits must add up to what's in the circle. And that's the case for all the arrows. This arrow, these two digits must add up to that digit. These three digits must add up to that digit. These two digits must add up to this one. Sorry, this one. And these two digits must add up to this one. And those are all the rules. It got a very hard rating, but there's only 21 ratings, so I'm not sure how difficult this is. Anyways, if you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, this has to be at least it could be 3 in one, so that means it could be 6 in the other one. So if it's 3 and 3, this would be 6 at minimum. Obviously, it can be up to 9. This could be 1 and 2. And then this could be up to 6. So then this would be 1, 2, 3, 4, 5. This has 3 digits that it's less than. But if it's 4, this would be 1 and 3, and this would have to be 1 and 3 also, which is not possible. So this has to be 5 through 9. This is the same as this one. So we're going to mark those as green. So the green has to be one of those 3. Huh. So this can't be 9 either. So 9 is either here or one of these 3. This is at least 4. This is at least 4 because you have 1, 2 plus 1, 1 plus 1, 2. This is at least 4 because of 1, 2 plus 1. Where is 9 here? Hmm. Yeah, I'm not good with arrow puzzles, so this actually might be very hard for me personally. Um, where are the 9s possible? So the 9 could be here or here. Could be any of these. So if it could be any of these. It cannot be any of these. It could be any of these 6. It can't be these. It could be any of these 5. Cannot be these 3, so it's any of these 6. Can't be this. Can't be this. This can't be, this could only be 1 through 7. And this has to be 1 through 6. Because this can be 3. So this could be 1 through 6 also. And this is 1 through 7. Oh, this could be 9 also. This is 1 through 6. This could be 1 through 7. These could be 1 through 8, 1 through 8, 1 through 8. Interesting. So these 2 digits must add up to what this is. These 2 digits must add up to what this is. Therefore, this is even. This is even. So to add up to an odd number, you have an even number and an even number. These 3 must be an odd number. You must add up to an odd number, but we don't know what that is. If this was 4, say this was 4, that would mean this is 1. This would have to be 1 and 2. So this can't be 1 or 4. This can't be 1 or 2. This can't be 1 or 4, so this can't be 4, obviously. Still could be, it can't be 5 anymore because it could be 2, 3, and 1. This is at least 2 and 3. So this would have to be 2 and 3 to be 5, and this would be at minimum 3 and 1. So this has to be 2, 3. Therefore, this would be 9. This could not be 1 or 3. This could not be 9. This can't be 2 or 3 here. So since this can't be 9, this can't be 6 anymore, and this can't be 7. This is 1, 2, and 3, which would force this to be 4, 5, and therefore that would be 9. So this cannot be 4. What about 5? This cannot be 4. Might be able to be 5. Oh, that's interesting. Yeah, that doesn't show anything though. That was interesting though that it required that. Therefore, this can't be 4 because of the same reasoning, right? If it was 4, it's well, not as completely. If this is 4, this is 1. This would have to be 1, 2. And this can't be 1 or 4. This can't be 1 or 2. So this is at least 3. So it could be 3 or 4. And this would have to be 2 and 3. So it's 2 and 3 with 3, or 2 and 3 with 4. Because if it's 2 and 5, that would be at minimum 10. So then this is 8 and 9. This can't be 2 or 3. This can't be 1 or 4. It can't be 2, 5. It can't be 3, 5. So this is 2, 3 also. Which means this has to have a 1, and it's either 2 or 3. Because this is 5, so this adds up to 3 or 4. So this is 1 with 2 or 3. The 2 has to be here, so this can't be 2. So this is 1 and 2. Therefore, this has to be 3, which makes this 8 and makes this 1, 2, 2, 3. This has to be 8. Right, because the 2 can't be here. It can't be that one. 2 can't be here, therefore 2 must be on here, so it's 1 and 2. So this can't be 8. So far it's okay. This has to be 4 and 5, which makes this 9. This can't be 9 or 8, so this has to be 3 and 4, which makes that 7. So far it looks fine. The 4 can't be here. The 4 can't be here. This can't be 4, so this has to be the 4. Which is a contradiction. So that's the contradiction there. So that just shows it can't be 4. Unfortunately, that's still... Well, okay, what about if we tried this being 4? Then this would be 1 and 2. Right? This can't be 1 or 2. So this would have to be 1. So there's no 1 here. There has to be a 1 here. So this is at least 5. So this is 4 at most. So it's 1 with 2 or 3. This can't be 1 or 2. This can't be 4. Therefore, this can't be 1 or 2, so no, this is 3 and 1, 2 at least, so this can't be. This is same thing here. This is 3 and 1, 2, so this is 6, 7, 8, and 9. This cannot be 2 and 5, because this cannot be less than 3. So it could be 2, 4, and this could be 1, 2. That seems fine. This can't be 1 anymore. So there's no 7 involved. It can't be 6 or 5 because this can't be 1 or 2. So if it was 2 and 5, this would have to have a 2 with it, which is not possible. So it could be 2, 4 with 3. This can't be 6 or 5. So it's 3 or 4. So this has to be at least 8. This is 2 and 3 at least. So this is at least 8, which means this can't be 8. So it has to be 7 at most. It could be 6, 5, 4, 3. Well, we know 2 is here. So this can't be 1, 2. So this can't be 3. This could be 1 and 3. It could be 1 and 4. Could be 1 and 5. Could be 1 and 6. Cannot be 1 and 7. It can't be 3 and 4. So the 1 has to be here, which means that can't be 1. So it can't be 1 and 7 here. This is at least 2. This has to be 3. And this is 2. This can't be 2. It cannot be 3 and 4. So therefore, this is the 2. This has to be 2 with 3 or 4. And this is 3. So this has to be 1 and 2. So this is 5 already. This cannot be 5 and 6. It has to have a 2 with a 3 or 4. So this can't be 3 or 4. So it's 1 with 5 or 6. So therefore, this is 6 or 7. This is 2, 3, or 4. So this is also 8 or 9. If this is 2 and 4 and 3, this is 9. If this is 1, 2, 3... Therefore, that would be 8. Yeah, that works. So far, this is looking fine-ish. This can't be 2 or 3. It can't be 1 or 2. It cannot be 3, 4. It could be 3, 5, or it could be 3, 6, or it could be 4, 5. So this is 8 or 9 also. Right? This doesn't work. This 8 or 9 has to be one of those three, and then it has to be one of those three, which means this 8 or 9 is this one, but then it has to be in the middle, which is impossible. Oh, that's interesting. So this can't be 4 because of that. But interesting. Say these both were 8 and 9. Hmm. Yeah. Hmm. Hmm. Can this be 6 is actually a question too, right? That forces this to be 1 and 2. Forces this to be 1 and 2, so this can't be 1 and 2. This has to be 1 and 2 then, which is fine. So that eliminates 5 from that possibility. This can't be 1, 2 anymore. So that can't be 1, 2, 3. So this can't be 6, and it can't be 6 anyways from that. This can't be 1, 2, or 6. So this can't be 5, and it can't be 6. This cannot be 5 anymore, but it could be 6. With 3, 4, 5, and 6. Ah, but if this is 6, this can't be 6 either. So, right? So then where is the 6 in column 5? It can't be here, can't be here, can't be here now because of this 6 making this a 3. So therefore, it wouldn't. This is not valid. So this cannot be 6 then. This can't be 6. This can no longer be 7. Um, this can't be 6 because if this were so this can't be 3 right now anymore because that can't be 6. This can't be 6 anymore because that would eliminate that as a possibility. It can't be 6 anyways, so this is 6. Therefore, this can't be 6. This is 4 or 5, which means this can't be 9, so that's 7 or 8. So 6 would have to be one of those 3. Whatever's here cannot be here, so it has to be one of these two. And therefore, it has to be one of these two. Hmm. This can't be 1, 6, because that would add up to 7, and then 7 plus 3 is 10. Could be 1, 3, 3, that's fine. This cannot contain 3 and 4. Well, I'm not sure if this is the path I should be going down. It is interesting, though. So we know at minimum These two add up to 3. These 3 add up to 6, and these 2 add up to 3. What does that mean? So that means these 2 must add up at least to 12. But it's at most 18, right? So it could be 1, 2, and 6, which would be 9, plus 1, 2, and then this would, well, If this is 1, 2, 6, and this has to be 1, 2, that would mean 1, 2 would have to be there, and that would be 6. But that's not possible then to be 1, 2, and 6 plus 1, 2 plus 1, 2 that adds up to 6. So this can never be 6. What about 5? 5 could be with 1, 2, and then you have... Actually, maybe you can have 6 there. So let's say, okay, so say this was 6 and this was 1, 2. This doesn't have to be 1, 2, right? It could be like 1, 3 or some combination. We know this is... So this is 9 then, if that's the case. This is 9, so therefore this would add up to whatever this is. What does that mean? Interesting. These 3 plus these 3 add up to these 2 digits. So this is 17 at most. Because this is 8 and 9 at most. We know it has to add at least to 12. To 17, you could have 1, 2, 3. That's 6. And then it has to add up to 11, which is 1, 2, and 8. So that's fine. Oh, okay. We have 1, 2, and 3 numbers that are all have to be different. And these are 1, 2, and 3 numbers that have to be different. So it could be 7, 8, 9, 7, 8, 9. So that would add up to 48 total for these cells. Right? That must add up to 48 at maximum. These 3 add up to 6 at minimum. These 3 add up to 6 at minimum. These 5 have to add up to 15 minimum. So this is 15 and this is 15. So that's 30. 36 plus 6 is 42. 43. So that's 43 there. That's possible. And I think that's the minimum we can have, right? Uh, So that's what, 5 degrees of freedom? So again, this is 15 at most, or at minimum. This is 15 at minimum for the red spots. This is 6. This is 6. This is 1. So 15 times 2. So 15 plus 6, which is 21, times 2, which is 42, plus 1, which is 43. So we have 5 degrees of freedom. So we can go up 5 from the 3, which we already knew that 8 was the maximum. The 1 could go up to a 6, but technically it can't because of that. The 3 can go up to a 8, but we've limited that. Um, so it's 5 degrees of freedom, which means a 7, 8, or 9 could go down to a 2, but we know it can't be, yeah, 2 anyways. Hmm. Hmm. Yeah, we just have 5 degrees of freedom, but I don't think that really tells us much. Uh, hmm. 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 That's interesting. Hmm. The 5 degrees of freedom do allow the 1 to be potentially a 6, so we're not guaranteed a 1 everywhere. Hmm. Fortunately, that doesn't tell us very much. Hmm. What can we do? I'm not good at arrow Sudoku, so yeah, this might take a while. Hmm. 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 What can we do? Are there any other limiting factors right now? Hmm. Hmm. Not that I can see. Obviously, this digit cannot be on this part, and it can't be here. But it could just be here, right? If it's here, it's problematic. Yeah, so this one can actually, this one can never be this one, right? If it's, well, no, because it would have to be 6 or 7. So if this one is the same, okay, so whatever this is, it cannot be on the same arrow. It can't be here because of Sudoku. Even if it was here, it would have to be 6, but then this would force this to be 1 and 2, and then therefore, where is the 6 in column 6? It can't be anywhere. It can't be there, because if it was there, then this would be, this can't be 6, because it can't be here. This would be 6, so it can't be there, and it cannot be one of these two, because that would be 6, that would force that to be 1, 2, and that to be 9, and there's no 6 possible. So this one cannot be here. It has to be here, and it has to be here. We know that for certain. Um, I think it works the same way here, right? If this is equal to one of the, it can't be obviously equal to one of those. So therefore, this one cannot be this one, cannot be any of these, because if it were here and it was, that would mean it was a 5, which would mean it's with a 1, and this would have to be 1, 2, and this would be 9, but there's no 5 then in column 4. So whatever this is has to be over here, and then has to match this, right? So there's that. Hmm. Hmm. I'm gonna need to go to the bathroom, so I'm gonna pause. And I'm back. Let's continue. Let's see. Hmm. 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 Let's try this as 3. If this is 3, this has to be 1 and 2, which means this can't be 1 and 2. This can't be 3. This is at minimum 3 and 4, so it's 3, 4, or it's 3, 5. Right, because it could be 1 with 1 or 2. So this is 1 or 2. This can't be 3. This can't be 1, 2, or 3. This can no longer be 1 and 2. So it has to be at minimum 1 and 4. And therefore this would be 4. This would be 9. This can't be 3 or 4. This can't be 3 or 4. This can't be 1, so this is 2. Therefore this is 3, 4 at least, and therefore this is 9. Which is not possible, because you would have a 9 and a 9. So this, because of that, we showed this can't be 3. But that's so little. I mean, anyways, let's try it this way. If this is 3, this is 1 or 2. Which means this can't be 1 or 2, this can't be 1 or 2, this can't be 3. This can't be 1 or 2, which means this is at least 3, and so this can't be 3 here. This is at least 3, 4, and it could be 3, 5. So this is 1 and 2 with it. This can't be 3. This can't be 1 or 2. So this can't be 4 or 5, because that would be 9 already. This can't be 1 or 2, so this would have to be at least 1, 4. And that doesn't work because this is at least 1, 4 also. So that can't be 3. I don't know if this is helpful, but... So why can't that be 3 is the question, right? It's sort of the way that it interacts, right? Because if this is 3, this 1, 2 gets eliminated, which means this has to be a certain thing. Can this be 4 then? Let's say it was 4, right? Then this has to be 1, 3. This can't be 1, 3. This can't be 4. This can't be 4. None of these can be 4. This can't be 1 or 3. This can't be 1 or 3. Okay, so this is at least 2 and 4. It can't be 2 and 7. It could be 2 and 6. So 2 and 4, that's 6. That means this is 1, 2, or 3. This is at least 1 and 2, so that still works with 1 and 5. This cannot be 7 anymore. This is at least 2 and 4. So this has to be at most 3. Can it be 4 and 5? Nope. So therefore this has to be 2, which means this can't be 2. So this is 5. This can't be 2 either because it's 2 and 4 at 4 and 5 would be the least. Therefore this is 2. This cannot be 2, and it can't be 5. This is 2, this is 2. That can't be 2, therefore this must be 2, right? So the 2 would have to be here, the 2 would have to be here. This can't be 2. So it would have to be, it can't be that one because that can't be 2. Therefore this would have to be the 2, which makes this 2 and 5, which is too big for that. So this cannot be I'm trying to figure out if there's a principle then that we have. So this can't be 3 or 4. So this is 5, 6, or 7. This can't be 3. Can it be 4? It doesn't necessarily affect it the same way. But this is 1, 3. This can't be 1 or 3. This can't be 1 or 3. This cannot be 4 or 5, so the 2 has to be here. So this can't be 2. The 4 can't be here. This can't be 4. This can't be 4. This can't be 4. This can't be 1 or 3. So the 2 has to be here. This can't be 7 anymore. This is 3 at most. This can't be... This is 5 or 6, so this can't be 5. Can't be 6. So this is 7. This is 8 or 9. It's either 1 with 2. So this can't be 1. This can't be 5 or 6. So this is 1 or 2 with 5 or 6. This has to be 2. Can't be 7. This has to be 2. Therefore, this has to be the 2. This can't be... So this is 2, which leaves still all the possibilities here. This, if it's 2, 4, it could be 2, which would mean that's 8 at least. So this is 8 or 9. This is 8 or 9. This can no longer be 2 and 6, so it has to be 2 and 5. This is 1, so this can't be 1. Therefore, this is 2, 4 with 2 would make an 8, or it's 9. So this can't be 6 because it can't be 2, 6, and 2. That would add up to 10. This is 8 or 9. The 1 has to be one of these 3. So this cannot be 1. So it's at least, it can't be 2 because of that 2. It has to be at least 3 and 4. And it could be up to 6. So this has 7, 8, or 9. So this has to have a 3 because it cannot be 4, 5 because that's eliminated. So therefore this can't be 3. Ah, but this 3, where is this 3? It can't be here. And it can't, it has to be here, which means it has to be somewhere along, this 3 cannot be any of these, but it can't be any of these because of this 3, and obviously it can't be here because this is 3, so that does not work. I'm trying to find a guiding principle that solves this, but I'm only so far just finding that it can't be certain numbers. So this can't be 4. Well, obviously, these arrows, so these circles cannot be along this arrow. But the problem is one of them could be on the other one. That's the question, right? Hmm. I'm not seeing any principles right now. These two obviously cannot be this one. One of them can be here. If one of them is this one, it has to also be there. Hmm. Huh. One thing I didn't see. Right. Well, no, never mind. I thought I saw something, but no, it's actually not the case. Never mind. Yeah, never mind. Uh, I thought I saw something where basically it limited these cells, the arrow cells more, but it didn't because I miscounted. Can we do all the arrow cells is the question. Does that help us any? I don't really know. Probably not would be my guess. Yeah, because these cells can be different ones, right? Hmm. What was great about these arrows and these circles was that they all lined up, so therefore it's 24 for each of them, right? And that means that we have 48. But the arrows themselves are fine. Ugh. Hmm. Let's say this was 1, 7, right? Therefore, this would be 1. This would have to be 9. This could no longer be 1. This could no longer be 9. So this is 2, 3 at least, and this is 1, 2 at least. So therefore, this would have to be 8. So then this would be 2, 3, which makes this 1, 2. So this is 1 and 2. So this can't be 1 or 2. So 2 has to be here, which means this is 2, 3 at least. So it's 5, and then this would be 3, 4 at least. So this is 2, 3, which means this is 8 or 9. It cannot be 9, therefore it's 8. Therefore, this has to be 2, 3, and therefore this is 3. So this can't be 3. Oh, wait, it's not 9. This is 8, so it'd have to be 2, 3, and therefore this would be 3. That works for the 2s and the 3s. This can't be 8. This can't be 8. This can't be... but you have 8 and 8 and 8. So this is not possible. Right, because it can't be the same digit. Oh, that's interesting, actually. Huh. So these two can't be the same digit. So that means it's 17 at most, right? Yeah, so these two added up have to be 17 at most. Which means this could be 1, 2, 3, 1, 2, and 1, 2. So this is 12 at least. So we have 5 degrees of freedom. The 2 can go up to the 7 still. So this can't be 1, 7 we just showed, right? Because then this would be 1, This would have to be 9 then. This would be 8. This not being a 1. This being 8. This not being a 1 means this is 2, 3, which means this is 1, 2. Which means this can't be 1 or 2. And the 1 can't be here. If this is... That's actually maybe a broader principle. If this is 1, this has to be at least 2, 3, which limits this a lot, which means the 1 has to be here. So this can't be 1. This can't be 1, and then this can't be 1, right? This is no longer 2, 5 is not possible, so it's 2 with 3 or 4. This can't be 2 then. This is also 2, but it actually could be 3, 4, and that's 2. That's possible. But if that's the case, say this was 3, 4, and this was 2. Therefore, this would be 9, and this could not be 9. Therefore, this would be 2, 3, and that would have to be 4. Or sorry, this would have to be 1 and 2. Because this could not be 9. So this would have to be 5, 1, 2. But we already know that that has to be 2 with 3 and 4. So this has to have a 2 here. So the 2 has to be here. The 2 has to be here. The 1 would have to be here. This is 2. Actually, that's a good question in general. Can this be 6, right? So say this was 6. This would have to be 1, 2. This would be 1, 2. So this can't be 1, 2. Which means this would have to be 1, 2. This can't be 6. This can't be 6. This can't be 6, obviously. This can't be 1, 2, or 6. This can't be 1 and 2, so this is at least 1 and 3, so this can't be 5. This can no longer be 7 or 6, because those require something less, 2 or less. This can't be 1, 2, or 6. So this is possible. 1, 2, 1, 2, 1, 2. The 6 is here. This can't be 6. This cannot be 3 and 4. So one of 1 or 2 is here. It could be 1, 3, 5. So this cannot contain a 1 or 2. Because 1 and 2 is here, 1, 2 is here. So this would have to be 3, 4, and 5 in some instance. Or it could be 3 and 6. So this can't be 5. It could technically be 7. This could be 1, 2. So this could be 1, 2, 4. It could be 1, 3, 4. That's fine. This is 1, 2 with 3, 4, 5. So this can't be 5. So, and this can't be 3 then. So this is 7 or 8. With 4 or 5. Again, this seems like it's fine in a sense. I think we went down this path earlier, and I don't think this is a good path to go down. One thing we did show, though, is that this cannot be 1, 7, right? If this is 1, 7, this becomes 1. Therefore, this becomes 9. This is a 2, 1. This can't be 9 anymore, so, and this can't have a 1 because we know 1 has to be here. So this can't be 1 or 2 because this has to be 1, 2. This is 2, 3. This is 8. Therefore, this can't be 1 and 2. This has to be 3 at least, and this is at least 2, 3. So that's 8 and 8. So this cannot be 7. I don't know if this applies here too. Maybe 1, 7. This is 1. So this has to be 9. This does not contain a 1 or a 7. This cannot contain a 1. It could be 2, 5. It can't be 2, 5, and 2. So this is 2. It can't be 3, 4, and 2 because this can't be 9. So this is at least 2, 3. And it could be with 2 or 3 here. So this has to have a 2. This can't be 1. And it can't be 9. Oh, that's interesting. So this is at least 2, 3. Which means this is 1. This can't be 9. This can't be 2. I mean, it could be 2. It can't be 5 or 4. This has to have at least 3. So this is not possible to be 5 or 4. It has to be 3. Therefore, this has to be 1, 2, which makes this 3, which makes this 2, 3. But then this would be 8, and this would be 8. So this cannot be 1, 7 either. But I don't... this is not... This, unfortunately, I don't think this works generalized, right? Well, it's just anytime you have a... Yeah, you have limiting factors there, like a 1 and a 9, and then a 1 also. Hmm. Well, we know the 7 can't be there then. Is it just 1 and 9? Maybe just 1 and 9 can't be the case, right? If that's 1 and 9, this can't be 1. This can't be 9, so this is at least 2, 3. Oh no, that 1 also there limit things. So this one couldn't be 1, but... So this is at least 2, 3, which means this is at least 5. This can't be 6, 5, or 4 anymore. So this can't be 1, because it's 1 with 2, 6, 3, 4, 5. So this can't be 9, this can't be 9. The 9 has to be one of those, so this can't be 9 either. This could still be 9. This can't be 7 anymore. It could be 6. No, it can't be 6. It could be 5. 2 and 5 plus 1. That's fine. This can't be 1. This is at least 2 and 3. This is at least 1 and 2. So there, okay, it has to be 1 and 3 and 2 and 1. 1 and 2 and 2 and 3. Therefore, this becomes 3. And this is 2, 3, and this is 8. But then you have... Maybe it is. Maybe, yeah, maybe you can't have 1 and 9 there. So the 1 potentially could be with something else. So, okay, yeah, we've shown 1 and 9 cannot be together here. That's all. Can we show this can't be 9 and 1? If this is 9 and this is 1, this obviously can't be 1. This can't be 1. This can't be 9. This can't be 1. This can't be 9. This is at least 2, 3. So the 9's here, which means this can't be 9. So the 9's here, so this can't be 9. This can't be 4. So this is 2, 6, or 3, 5. This is at least 2, 3. So therefore, that forces this to be 1. So this is 2, 3, and it has to be 1, 2 to form 8. So this can't be 2. This has to be a 2. This can't be 2 or 3. This has to be at least 2 and 3, but then it would be 3 and then 2, 3. And this would be 8, and that's not possible. Yeah, so 1 can't be with 9 in either of those spots. 1 cannot be with 9 in either of those spots because that forces an 8-8 situation. Um, hmm. Oh, one interesting thing is 1 can't be in any of these corners either. Actually, it can't be in any of these corners. It might be able to be in one of these corners, maybe. If it's in one of these corners, that means it eliminates 1 here and 1 here, which means the minimum is 2 and 3 and 2 and 3, which adds up to 10. So 1 cannot be here. What about here? Can 1 be here? If 1 is here, say it's here. This could be 2, 3, and 2, which would add up to 7. This could be 1, 3, and then, yeah. So 1 could be over here, technically. I don't know if it is. Mm-hmm. Hmm. What does that mean? Does that mean anything? I don't know. We just know 1 can't be here. 2 could be here potentially. What if 1 is here? Let's just try it. So say this is 1. Then this can no longer be 1. This can no longer be 1. This can no longer be 1. That's interesting. Bingo. Okay. That can't be the case. Well, maybe. Maybe not. Hold up. We lost all our degrees of freedom here, essentially. This is 2, 3, 4, 5, 6, then. We lost all our degrees of freedom because the 1 can no longer be here. So then this would have to be 1, 2, and 3. So this would have to be 1. This would have to be 2 and 3. But the problem is this can't be 2 or 3 or 1. Yes, 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 yes. Okay. So, yeah, because we lose all our degrees of freedom in this row, just from this row for those, remember those 4 arrow set that I made? Or the arrow set that I made, this arrow set. This has to add up to 48 at most. And we lost, so therefore, and we have a minimum of 43, so we have 5 degrees of freedom. The 1 has to go up to a 6, so we lose all 5 degrees of freedom in this row. Therefore, everything else has to be the minimum, which means this has to be 1, this has to be 2, 3, but we also lose the degree of freedom here for the 1, right? So the 1 can no longer be here. So we lost 5 degrees of freedom here, and we lost 1 degree of freedom here. So that's 6 degrees of freedom, which we do not have. We only have 5. Therefore, that cannot be 1. And it's the same thing here. If this is 1, we lose 5 degrees of freedom here, and we lose 1 degree of freedom here. So therefore, that's 6 degrees of freedom we lost when we only have 5 available. Therefore, the 1 cannot be in either of these places. So the 1 has to be here. Now, I don't know what that really tells us, unfortunately, but I don't think it applies to the 2 the same way. The 2 can go up to a 6. That's 4 degrees of freedom lost. Oh, I don't think the 2 can go in into the corners either. If the 2 is in one of the corners, so the 2 is, say, in one of the corners, that means we lose 4 degrees of freedom there, right? We have one more to play with. But the problem is, if the 2 is here, if we have the 2 be here, then it cannot be in any of these 3, right? So the 2 would have to be here. But then the 2 goes up to the 4, right? Instead of being 1, 2, 3, it has to be 1, 3, 4, which is another 2 degrees of freedom. So the 2 can't be in any of the corners either because of that. So this has to be 1 and 2. Interesting. I don't know what this tells us, but yeah. 3 I don't think works that way. 3 I don't 3 you lose 3 degrees of freedom. Oh, okay. To continue too, also. Now, let's say you can say, hey, what if this is not 2, right? The problem is then it's the same way this way, right? So this can't be 2. If this is not 2, say this was a 2, then this is the 2, and therefore you lose the same 2 more degrees of freedom there. So therefore we know 1 and 2 have to be here. I don't know if it works the same way with 3. If you have 3 going to 6, so you lose 3 degrees of freedom. If this was a 3, this could still be 1, 2, and 4, right? So if that's the case, so you lose 3 degrees of freedom here. We still have 2 to play with. Say this was 3. This could still be 1, 2. And then the 3 would be here. You could have 1, 2, 4, and that's 1 degree of freedom that we lose. So that is fine. Hmm. Hmm. Yeah, that seems okay. Hmm. So again, we're thinking of these arrows as the constraint. We know these two can't be the same, so it's 17 at most, but that doesn't limit us enough. Hmm. We know 1 can't be with 9 specifically here. But I think it could work with anything else. Right, because, okay, so if this is 1, this has to be... Okay, well, 1 would have to be one of those 2. Because we know 1 is here. This can't be 1. This can't be 1. This can't be 3, 4. Because then this has to be at minimum 3. So this would have to be 2 in something. And it cannot be 2 and 5. So the 2 would have to be here. This can't be 2. So this is at least 2 and 3, which is at least 5. So this can't be 6 or 7. So this would be 8 or 9. This is 1, 2, with potentially 3. So this can't be 1. So this could be 2 or 3, or 2 or 4, with 1 or 2, or 1 or 3. This has to be at least a 2, because we know 2's here, we know 2's here. Where's the 2 in column 6? It has to be one of these two spots. It cannot be 7 anymore, cannot be 6 anymore. It could be 2, 5. So it could be 2, 5, 2. This is 9. Oh, but that can't work, because then this would be 1, 3. This would be 2, 3. So this cannot be 2, 5. So this is 2 with 3 or 4. The 2 could be here. If this is 2, so this is at least 7. So far this is working okay. Yeah, so it doesn't look like 1 is a limiting factor necessarily just there. Oh, this one too. All we know is that this can't be 1 and 9. And this can't be 1 and 9. About these factors. These still can be 1. This can never be 1. So this is 3 through 9, 3 through 9, 3 through 9, 3 through 9. That doesn't help us much. Can this ever be 5? If this is 5, this has to be 1, and then therefore this is 1, 2. We've lost 4 degrees of freedom here. So this is at least a 3 or 4. This is 9. This has to be 2. So this has to be 1. This can't be 7. This can't be 9 anymore. This can't be 1. So this is at minimum 2 and 3 and 3. So this is 3. This is 2 and 3. Therefore this is 8. This can't be 5 or 8. This can't be 5 or 8. This can't be 2. This can't be 1 or 2. This can't be 3. This can't be 8. So we've lost 4 degrees of freedom. Therefore, this cannot be 2 and 3. This can't be 9. This can't be 9. This is at minimum 1 and 3, so this has to be 7 or 8. So this cannot be 5 or 6. This can't be 5 or 6 because this is 3, and 1, 5 with 3 would add up to 9, so it's not possible. We've lost 4 degrees of freedom, so the 1 and the 2 have to be here. So this has to be 1, 2, 1, 2. So then this is 5, but then we lose, that means we lost another 2 degrees of freedom there. Because the maximum we were saying was 7, 8, and 9. But that doesn't work with the 5 being there. And in addition, the 5 it has to be there, which means the 5 is there, which means this can't be 5. But where else are 1 and 2 going to be? 1 and 2 have to be here because of the 1, 2, 3 discrepancy. So therefore, that only shows that the middle digit in the whole grid can't be 5. That doesn't tell us that much, unfortunately. Um, hmm. Yeah, that doesn't tell us much. Um, hmm. Again, we have 5 degrees of freedom, so the 5 can go up to even a 9 technically, but it can't be because obviously arrows can never contain a 9. But 1/8 still seems valid. So these 3 equate to these 2. Obviously, it can only be 17 at most, which means this is 1, 2, 3, 1, 2, 3, 1, 2, 3. So it's 5 degrees of freedom that way. And it's same here for these and then these. That would be 5 degrees of freedom. Huh. But we know overall you can't have 5 degrees of freedom. Right? So overall, you only have 5 degrees of freedom, period, amongst everything. So this 5 degrees of freedom so this is at least 12, and this is at most 17. This, there's no restrictions on. Yeah, there's no restrictions. Yeah. But if this is 1, 2, and 3, therefore this is 4, 5, and therefore that's 9. Does that give us anything? Not particularly. I mean, this can't be 9, so therefore you need to have a 1, 2, or 3 there. Which is, I mean, fine. Hmm. So obviously, if one of these is 5, the other one has to be at least 7. So it's 7, 8, or 9. If it's 5, you lose 2 degrees of freedom. Hmm. But that doesn't seem to limit anything. Hmm. Hmm. Yeah. Hmm. Um, what else could we try? I mean, we could try this as 4. Hmm. Yeah, but that doesn't help any. Hmm. This being 1-7 seems like it's bound to fail. So let's try that. If this is 1-7, this is 1. This is 1, which means this can't be 1. This is 9. This can't be 9. This can't be 1. This can't be 7. This can't be 1. So this is at least 2, 3. And so it's 2, 3, 2, 3, or 2, 4 with 2 or 3. So obviously this can't be 1. This has a 2. And if it's 2, 3, it could be with 3. So this has to be 8. So if it's 2, 3, this is with 3. If it's 2, 4, this is with 2. This can't be 7. This can't be 7. This can't be 3 or 4. It can't, so it has to be 3 and 5, which means this can't be 9. It can't be 5 or 6, so this is 8. Which means this is 5 or 6. That's interesting. This can't be 8. It can't be 9 because of this 9, right? The 9 has to be here, then here. So this cannot be 6 or 7. This is 2 and 3, 1 and 2. Okay, so this can't be 1 and 7 then. Yeah, so that we got limiting factors. So this can't be 7. But it doesn't. It feels like part of the problem is this just seems like one-offs that I'm trying out instead of actually like having some sort of principle that basically can like say, hey, because of this limiting factor, we can eliminate a whole bunch of stuff. It's more just, oh well, we can eliminate stuff, but it's, we don't really know what it is. Hmm. Hmm. Can we limit things by just these? Maybe. So this is 15. This is 6 at least. So that's 21 at least. Um, if this is 9, this could be 8 and 8. Hmm. I don't think that leads anywhere. Hmm. Hmm. Say we do have the maximums here in these circles, right? So say this is 6, this is 5, this is, sorry, cannot be 6, cannot be 5 or 6. Say it's 7, 8, and 9, right? That would mean both of these cannot be here. And it cannot be on, well, it could be on here. Ugh. Never mind. This one would obviously not be here or here or here. So it would have to be one of those two. But that doesn't tell us anything, right? Hmm. 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 Now that's interesting. What if this is 5? If this is 5, this has to be 1 and 2 here, right? Because this adds up to 6, this would be 3, this adds up to 9. So this can't be 9. This can't be 1 or 2. This has to be the 2. So 1 and 2 have to both be here, which means this is 5. So there's the same problem here. Where is the 5 in column 6 or 4? 5 has to be here, 5 has to be here. The 5 would technically have to be in this one, but that's not possible. So this can't be 5 either. I don't know if that tells us anything. Hmm. Um, hmm. If this is 5. Hmm. Right, that's why I was like contemplating the 3s. But it could be 1, 2, 4. 1, 2, 4. Hmm. Hmm. Can't see it right now. Hmm. It could be 1, 2, 4 though. Hmm. Yeah, that's why I was thinking. So we know. Do we know 1 and 2 have to be there? I think so, right? 1 and 2 has to be here, here, or here. Assume it's not, right? Hmm. Well, the only other place could be here, right, for this one. So assume 1 was there. This would be 2, 3, 4, 5, 6. This would have to be 1 then, because we lose our degree of freedom. So if this is 1, this is 2, 3, 4, 5, 6. We lost all 5 degrees of freedom in the reds. So this has to be 1 then. This has to be 1 through 5. So this is 1. This can't be 1. This can't be 1. This can't be 1. This has to be 1, 2, or 3. This is 1, 2, or 3. This obviously has to be 7, 8, 9, 7, 8, 9, 7, 8, 9. So this is 2 through 6. And this can't be 6. This is 1, 2, 3, 4, 5. So 6 cannot be any of these two, but 6 could be that one. Ah. Ah, that's interesting. That's a contradiction then. Because these would then have to be 7, 8, and 9, and we have 3, 7, 8, and 9s there. That's interesting. Okay. Maybe we can work with that. Maybe. I don't know. So therefore, the 1 has to be in one of these 5 red marked cells. Interesting. Okay, so what happens if we do have 7, 8, and 9 in each of these columns? Well, these can't be 7, 8, or 9. This could be 7, 8, or 9, and this could be 7, 8, or 9. So this would also have to be 7, 8, or 9. Obviously, it couldn't be 9. Same here, right? So one of these would be 7, 8, or 9. One of these would be 7, 8, or 9. It obviously couldn't be 9. And one of these would be 7, 8, or 9. Then this would have to be 7, 8, or 9, 7, 8, or 9. And one of these would have to be 7, 8, or 9. Oh, wait, that doesn't work. Oh. Huh. Okay, so yeah, again. If this was 7, 8, 9, 7, 8, 9, 7, 8, 9, where are these two going to go? They can't go to this. They have to go both to here. But the problem is then you would have at least 4 from 7, 8, and 9 in column 6. So it doesn't have 5 degrees of freedom. It has 4 at most. At least. I don't... Yeah. Right. So therefore, you don't have 5 degrees of freedom. You have 4 at most. So 1 always does have to be here. What about 2? If 2 is here, this could be 6 through 9. This could be 6 through 9. This could be 6 through 9, 6 through 9. And this could be 6 through 9. So we have 1, 3, 4, 5, 6. This would be 7, 8, 9, 7, 8, 9. So that does work. This would have to be 1, obviously, because we lost all our degrees of freedom again, because it has to be 6, 8, and 9 at most. So the rest of this cannot be 6. This can't be 1. This can't be 2. This can't be 2. So therefore this is 2. This can't be 2. This is 1, 3, 4, 5, and 6. So this can't be, it could be 6. This has to be 3, 4, 5. This is 3, 4, 5. Ah, we have a contradiction then. Because this has to be, we lost all our degrees of freedom with the 2 being outside of these 5. But the 2, oh, the 2 is, no, we have a contradiction. So we lose another degree of freedom if the 2 is here, right? Or sorry, if this is 7, 8, 7, 8, 7, 8, 9, 7, 8, 9. This has to have one of 3, actually has to have 2 out of 3, 4, or 5. So we lose at least 2 more degrees of freedom, and we already were limited to the number of degrees of freedom we had. Therefore, 2 can't be outside there. Maybe we can figure out if 3 can be outside in the middle box. That's actually an interesting question now that we've shown that. First of all, we only have 4 degrees of freedom at most, because we tried having 7, 8, 9, 7, 8, 9, 7, 8, 9 in all of column 4s and 6s, but then that eliminates 7, 8, 9 as possibilities in all of the rest of box 5, essentially. So what happens if we have a 3 here, like, say? That would mean we lose 3 degrees of freedom. We still have 2 available, so that's still okay-ish. This obviously can't be 3 anymore. This can't be 3. This can't be 3. This could be 1, 2, 4, 5, 6. It could be 7 or 8 also, taking that into account. If this is 3, we lost 2 degrees of freedom. 3 degrees of freedom, so we only have 2 left. So this cannot go up to 4, because that's 3 degrees of freedom required. We have 2 degrees of freedom, so 5 can go up to 7. So this 6 could go up to 8 still. So that's still possible. The 7 could go down to 5, so that's fine. The 3 can no longer go up to a 6, so this cannot be a 6. This cannot be a 6. It could be 1, 2, 4. In fact, we know one of them is 1, 2, 4. So those are all our degrees of freedom, I think. Right? Okay, so say, okay, so the 3 makes this go from 3 to 6. So that's 3 degrees of freedom lost. This could also be considered a set of 3, and along with this set of 3, right? They don't intersect with these. They do intersect with these 3, but essentially this acts as its own set of 3. So this would be 1, 2, 4 at minimum. So we lost another degree of freedom. We've shown 7, 8, 9 does not work. So then this would have to be one of them 6, 8, 9, and one of them 7, 8, 9. Right? So then we lost all our degrees of freedom. So this can't be 7 or 8. This can't be 7. Therefore, this is 7, 8, 9. This is 7, 8, 9. This is 7, 8, 9. This can't be 8. This can't be 6 anymore. This can't be 6. So this, we have a problem. 6, 7, 8, 9, 6, 7, 8, 9, 6, 7, 8, 9, 6, 7, 8, 9. Right, because we lost all 4 degrees of freedom here. We've shown 7, 8, 9 does not work, so we don't really have 5 degrees of freedom. We have 4. This 3 being here eliminates 3 degrees of freedom here and 3 degrees of freedom here. Sorry, 1 degree of freedom here, which means that the 47, the actual 4 degrees of freedoms we have are all used. Therefore, this cannot be, this has to be 1, 2, 4, 5, 6. These have to be 1, 3, 4, 1, 2, 3, 4, 5. But that means that the leftover ones are 7, 8, and 9, and this is 6, 7, 8, and 9. And that's not possible because we have 5, 6, 7, 8, and 9s in box 5. And I think that works for all the 3s. In the corners of box 5. Right? Because if this is 3, we lose 3 degrees of freedom here. We lose 1 degree of freedom here. So that's 4 degrees of freedom that we've lost. And we can't have 7, 8, 9, 7, 8, 9, 7, 8, 9 in both column 4 and column 6 because they can't go then. Yeah, there just aren't enough spaces, right? So then this becomes, if this is 3, this would become 1, 2, 4, 5, 6. This would be 1, 2, 3, 4, 5. Therefore, you have 6, 7, 8, 6, 7, 8, 9, 6, 7, 8, 9. This would be 7, 8, 9, 7, 8, 9. And these would have to be 6, 7, 8, 9. So that's too many. So 3 cannot be in the corners either, right? And same here. If this is 3, this becomes 1, 2, 4, 5, 6 at least. This becomes 1, 2, 4 at least. This is 1, 2, 3, 4, 1, 2, 3, 4, 5 because we've lost 4 degrees of freedom, and this has to be 6, 7, 8, and 9. So 3 cannot be in the corner either. Therefore, we know this is 1, 2, and 3. Okay. That's kind of crazy, but yeah, that's interesting. So this is 4, 5, 6, 7, 8, 9. We know at least one of 1, 2, or 3 has to be here, and it has to be here. It could be 2 out of 2, 1, 2, or 3 have to be there, right? So 4 could work because we don't lose any degrees of freedom here. We would lose obviously 2 here, and we would still have 2 left. Hmm. What else do we have then? This still could be 1 and 8. This still could be 1 and 8. We know 1, 2, 3's here, but that doesn't really help us much. right? Because that means this is just 4, 5, 6, 7, 8, 9. But this could be a 1, 2, or 3. Obviously, we could have two of them here, and then the last one here, and then here. Hmm. 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 This has to be 3 through 9. We didn't test the 3 being there. I don't think it's as limiting, right? If the 3 is not here, then we only have 3 degrees of freedom that we lost, so we still have 1 degree of freedom somewhere. Um, hmm. Yeah, and this doesn't have to be 1, 2, 3, 4, 5. Just like this doesn't have to be 6, 7, 8, 6, so 6, 6, 8, and 9, or 7, 8, and 9. Hmm. Hmm. I'm trying to think if I'm actually double checking my 7, 8, 9 assumption. Um, because it might be wrong. I'm trying to think. Again, what happened? So say this was 7, 8, 9, 7, 8, and 9, and 7, 8, and 9, right? Hmm. Yeah, I don't know if that's the case. Hmm. That might be I was hoping that that was a break, but that doesn't look like it. Hmm. Actually, I think it still does work for 3, right? I just don't think the 7, 8, 9, like the 7, 8, and 9 thing is not necessarily a guarantee. Let's look for it. Let's look for it specifically at 3, right? If this is a 3, again, that we lose the 4 degrees of freedom here. Sorry, 3 degrees of freedom from going to a 3 to a 6. So therefore, that's 3 degrees of freedom. We also lose the 1 degree of freedom here. So that's 4 degrees of freedom lost. So the maximum is 7, 8, 9, 7, 8, 9. That means it can only go from 6 to 8, 6, 7, 8, 9, right? So this can only be, okay, this can only be 6, 7, 8, 9, 6, 7, 8, 9, and 6, 7, 8, 9. Because of that. So then this has to be 1, 2, 4, 5, 6, or it could be 7. Um, that's could be 7 is doing a lot of work. But this is 1, 2, 3, 4, 5, and the 5 could be a 6, right? So this is 1, 2, 3, 4, 5, 6, 7, but the 6 could be a 7. So this still becomes 6, 7, 8, 9. This is 6, 7, 8, 9, 6, 7, 8, 9, right? Because we only have 1 degree of freedom left. And this is the same with 1, 2, 3, 4, 5. 1, 2, 3, 4 have to be in the 5 red boxes. So this becomes 5. Well, that does work, though. This could be 5, 6, 8, 9. So this would have to be 6, which means this would have to be 5. Which means this cannot be 5, and this cannot be 3, and this can't be 6. So it's 1, 2, 4. This can't be 5 anymore. This can't be 5. So it's 1, 2, 3, 4, 6. So we've lost our last degree of freedom. Therefore, this has to be 1, 2, and 4. This has to be 1, 2, and 4. This has to be 1, 2, or 3. This is 1, 2, or 3. So this would be a 4 then, which means this can't be 4. So this would have to be a 4. And this would be 1, 2, and 3. This can't be 1 or 2, so this is 3. This can't be 1 or 2. So this so far still works. The 6 has to be one of these two. So this can't be 6 because it would be 1, 6 at minimum. Therefore, this has to be 6. So this can't be 6, this can't be 6, this can't be 6, and this can't be 6. We lose the 7 here because we've lost our degree of freedom from the 5 to the 6 here because the 5 is one of these two. Therefore, this has to be 1, 2, 4, 5, 6. So therefore, this can't be 6. This can't be 6. So one of these two is 6. This has to be 6, so this can't be the 6. Therefore, this is the 6. Ah, but then this can't be 6. Okay, so this is... Okay, this is only for this specific one. It might be different for others, maybe. We know the 6 has to be here, and the 6 has to be here, but then it can't be anywhere here, right? Unfortunately, this isn't very general principled, but yeah. I think, though, it works for everything else, right? If this is 3, this becomes 3. Well, let's try the opposites. Well, but... Right, this is 3, this is 1, 2, 4, 5, and then 6 or 7. So this is 1, 2, 4, 5, 6, or 7. This obviously can't be 3. This has to be 1, 2, 3, 4, and 5 or 6. So this becomes 5, 6, 7, 8. This is 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9. This is 5, 6, 7, 8, or 9. Why did the 5 have to be down here? This could be 6, 7, 8, and 9. Oh, this has to be 6, 7, 8, and 9. Right, because these both have to be 6, 7, 8, and 9 because of the limitations of the 4 degrees of freedom that we lost. So this is 6, 7, 8, 9. This is 6, 7, 8, and 9. Therefore, the 5 has to be here, which means this has to be not 5. This can't be 5. Therefore, we know this has to be 1, 2, 3, 4, and 6. So 6 can't be here. 6 can't be here. This is 1, 2, 3, 4, 6 now. And this is 1, 2, 4, 5, 6. So we've got lost, and this is 1, 2, 3, 1, 2, 4. So therefore, this has to be 1, 2, and 3. This is 1, 2, 4. This can't be 7 anymore. So this is 6. So this can't be 6. This can't be 6, and this can't be 6. But the problem then becomes one of these is 6 and one of these is 6. Either one, and then this can't be 6 either way. So yeah, we've shown that we cannot have 1, 2, and 3 in the corners. Well, okay. We have to try the other ones. Actually, I think the same principle holds everywhere, right? So the principle is that basically, if you have a 3 on the outside somewhere, you're losing 4 degrees of freedom. So you're losing 3 here along one of these 5 sets, right? Because the 3 has to go to a 6. And you're losing 1 here, which is the 1, 2, 3 has to go to 1 to 4. Therefore, you only have 1 degree of freedom left. That means the 5 goes away in the 5, 6, 7, 8, 9s for the circle. So it's either 6, 7, 8, 9. It's either one of them has to be 7, 8, 9, and one of them has to be 6, 8, 9. And then, so you are limited then in the other, so in the 5 that you have the 3 on, the 3 that you have to go to 1, 2, 4, 5, 6, or 1, 2, 4, 5, 7. So the rest of the numbers have to be 5, 6, 7, 8, and 9. Because 1, 2, 3, 4, and 5 are all eliminated in that row. For the other set, it has to be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 6. Because we have, again, only 1 degree of freedom left. And therefore, that's 1, yeah. So therefore, the other numbers in that row has to be 5, 6, 7, 8, and 9. And because there's one of the corners is a 3, we have 5 other numbers which have to be 5, 6, 7, 8, and 9. So therefore, the one that has the 1, 2, 3, 4, 5, 6, this can no longer, row 5 can no longer contain 5 in the circles because we are limited by the 4 degrees of freedom that we lost, so we only have 1 degree of freedom. So the 7 can only drop down to a 6. And then in addition, the row that the 3 is no longer on must contain a 1, 2, 3, 4, or must not have a 1, 2, 3, or 4. So that has to be 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 6, 7, 8, 9, 6, 7, 8, 9, 3 with another 6, 7, 8, 9. And therefore that becomes 5. Therefore we know the set of 5 becomes a 1, 2, 3, 4, 6 because the 5 has to be in one of these 2 cells or one of these 2 cells in box 5. Whichever one the 3 is not on. So then that forces, so that we lost our final degree of freedom. So that's 1, 2, 3, 4, 6. And therefore, the 6 doesn't work anymore, so then we don't have a 6 anywhere. So therefore, this is 1, 2, and 3. We know that for certain then. So we've just shown 1, 2, and 3 have to be there. Okay, so these are 4 through 9. These are 4 through 9. Ah, man. Yeah, this is definitely very hard. um, hmm. 4 doesn't have the same restricting aspect to it. Because you only lose 2 degrees of freedom one way, and you don't lose any degrees of freedom in the other way. Hmm. This still could be one from one. Hmm. Hmm. Yeah, so the 7, 8, 9 going down, I don't think that's correct. I think you still have the 5 degrees of freedom. It's just in the specific cases of 1, 2, and 3 that was limiting things a lot more. And so therefore there's issues with that. But I don't think 7, 8, and 9 necessarily have a restriction for the circles. That's not good. Hmm. I mean, it is good that we finally got down to this has to be 1, 2, and 3, but... Uh, Oh, that is interesting, though. That means 4 has to be one of these two and one of these two, which automatically limits the 1, 2, 3, 4, 5 by 2 degrees of freedom. So we lose 2 degrees of freedom now, again. So we have now 3 degrees of freedom remaining. Because the 4 has to be in one of these 4 cells, right? Yeah. Okay, so that's interesting then. If that's the case, that means we only have. So in the non 5 cells, we only have 3 degrees of freedom. Well, okay, that's that then proves that the 7 can never be here. But that doesn't show very much. Mm. Hmm. So we know there's only 3 degrees of freedom in all the other cells, but the problem is that doesn't help us. Um, hmm. If one of these is 6, that's all our degrees of freedom then. So it's 1, 2, or 6. Therefore, this has to be 1 or 2. Therefore, this has to be 1, 2, or 3, which means this is 1 or 2. One of them has to be 4. Obviously, the 6 cannot be here. This can't be 6. This can't be 6. So then this would have to... Oh. That's a problem. This would have to be 3. But then we know this has to be 3. Okay, so it can't be 6 then. Right? But, So this can't be 6 specifically. If this is 6, it has to be with a 1 or 2. Right? So then this is at least 8. We've lost all 3 degrees of freedom because we know the 4 has to be in the corner. And therefore, it eliminates the 4 from... So it has to be 1, 2, 3, 5, 6. The 6 already being there means... this can't be 6. This has to be 1, 2. Which means the other side has to be 1, 2, and 3. But the problem is then where's the 3 here? The 3 cannot be any of these. It cannot... Yeah. So it cannot be 6. Can it be 5 then, if that's the case? Maybe... I don't think it could be 6 for any of them, though. Let's try with... Say this was 6. If this is 6, this becomes 1, 2. Therefore, this is 3. Therefore, this is 1, 2. Yeah. So it can't be 6 there, because then this would have to be 6. But that's only that specific one. Then this would have to be 4, 5. So what happens about the other side? Can the other side be 6? So then we know 6 cannot be here or here. What about this? If this is 6. If this is 6, then this becomes not 1, 2. So this is 1, 2. This has to be 3. This has to be 1 and 2. This looks like it does work, actually, here. So this can't be 6. This is 1, 2, or 3. This has to be 3. Therefore, this is 1, 2. It cannot be 7, 8, or 9 anymore. So this has to be 5. Which means this is 2, and this is 1. Right. So this can't be 2. This can't be 1 or 2. So this can't be 5 anymore here. This looks all fine. So it's 4, 7, 8, 9. This is 3. This can't be 6. This can't be 6. This is 1, 3, and 1, 2. So therefore, this is 7. This can't be 7 then. This can't be 7. It also can't be 4 in either of these. So this has to be... This can't be 6. But this could be 6. 3, 4, 5, 6. This can't be 3, so this has to be 4 and 5, which makes this 9. So none of these can be 9. So this has to be 9, which means this can't be 9, which means this has to be 9. So far it's looking okay. This is 4, 5. This can't be 4, 5. Ah, this is 1 and 3, which means this has to be 7. So that's a long-winded way of saying that can't be 6. Hmm. Okay, so then 6 is eliminated from... Huh. This is... Yeah. Hmm. This does have to be 3 through 9. Does it? I don't even know. I don't think it's worth putting there for now because we don't... I don't know if I was messing up somewhere there before. Um... Hmm. Can this be 6? So it would be with 1 or 2, obviously. Then this would also be 1 or 2. This would have to be 8 or 9. Because it's 1, 6 at minimum, and then that would be 1 at minimum. So that's 8 at minimum. Therefore, this can't be 6. One of 1 or 2's here. Hmm. Maybe. This seems like it could very strongly be. Uh, if it's 6, that means we don't know what it's in place of, though. Hmm. 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 It's a 5. Yeah, we don't know. Hmm. 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 I'm gonna pause right now because I need to get some food. and my brain's not working very well right now without the lack of food. So I'm gonna be taking a break for a little bit. I'll be back in a little while. Okay, I'm back from my meal. So ready to go at this again. If you noticed, I turned on the lights because it's getting really dark here. Um, and let's continue. Okay, so one thing I was thinking of while I was eating is that one of these has to be four, right? So we lose 2 degrees of freedom there. If this were 5 and 6, which I don't think it can be. If it's 5 and 6, that means the 7 goes down 2, and the 7 goes down 1, which loses our additional 3 degrees of freedom. In addition, this would have to be 1 through 5. This would have to be 1 through. Maybe we should just try it. So no 5, 6, no 5, 6. 6. This would be 1 through 5. This would be. Therefore, this would have to be 8 and 9. This would be 8 or 9. This would be 8 or 9. This would be 8 or 9. Oh, that doesn't work because this can't be 8 and 9, 8 and 9, 8 and 9, 8 and 9. There you go. Let me also rethink. So it cannot be both 5 and 6, but it possibly could be neither. 1, 5 and 6, and 1, 5 and 1, 6, and something else. Let me revisit the 7, 8, and 9 to see if I can figure that out. Okay, that means 7, 8, and 9. Oh, yeah, there you go. You can't have 7, 8, and 9. So we actually only have 2 degrees of freedom, right? So if you maximize these numbers, it's 7, 8, 9, 7, 8, 9, 7, 8, 9, 7, 8, 9. All 7, 8, and 9 gets eliminated here. All 7, 8, and 9 gets eliminated here, except for the circles. And then we have 7 cells, which must contain 1 through 6, which is not allowed. So that's why you can't have 7, 8, 9. So that was correct. So we actually only have 2 degrees of freedom. Again, the 6 can go up to an 8. 3 can go up to a 5. Okay, so we are eliminated. We already eliminated all the stuff that we needed those degrees of freedom for. So this can still go up to 8. This can still go up to 8. Because the 6 can go from an 8, and then you have a 4, right? So you have 1, 2, 3, 5, and 8. So the 4 essentially jumps to an 8. Say this was 5. If this is 5, this has to be 1 or 2. 1 or 2. And this cannot, so then this cannot be 5. This cannot be 5. This cannot be 5. Therefore, this is 5, so these can't be 5. This would have to have a 1 and maybe a 2 over 3. So this cannot be 1, 2, or 3. Therefore, this would be 4, 5. Therefore, this would be 9. This cannot be 4 or 5. This couldn't be 4. None of these could be 9. Obviously, this could be 9. So this would have to be 4 and 9. Sorry, 4 and 5 here. Which is not possible. Right? Because then this becomes 1, 2, 3, 5, 6, 7. Or 1, 2, 3, 6, 7. And we've lost all degrees of freedom. Wait, do we? No, hold on. The 4 goes up to. Actually, that's still possible. So this could be one. Okay, this cannot be 4, 5. This becomes 1, 2, 3, 6, 7. 1 cannot be here, so this can't be. This can't be 7 anymore because of that, so it has to be 2, 6, which makes this 8. So this can't be 8. This can't be. This can't be 2, so this has to be 1, 3, and this is 1. So this can't be 1. This cannot be 9. It can't be 5. This can't be 1. This can't be 8. This can't be 9. This can't be 2 or 6, so this is 1, 3. So that's not possible. Okay. Well, we just shown that's not possible. Interesting. I wonder if we can show the other side too. Probably. So this can't be 5. What if this is 5? This is 5, then this again becomes 1 or 2. This has to be 1 with 2 or 3. This can't be 1. This has to be 4, 5, which makes this 9. This can't be 5, obviously. It can't be 9. This can't be 5, and this can't be 5. This is 1. So this cannot be 1. It has to be 2. This can't be 4, 5. This can't be 4, 5. This can't be 4. So therefore, this has to be 4 and 5. This is 4 and this is 5. Which makes this 1, 2, 3, 4, 5, 6, 7. But the 1 can't be here. Therefore, this doesn't work. Because this cannot have 1 and 7 anymore. Because the 9's not there. So that doesn't work either. Okay. Good to know. So this can't be 5. Can this be 5? Maybe similar. This can't be 5. This can't be 5. This can't be 5 because this is 5. This obviously can't be 5. This can't be. This has to be 1. So this can't be 1. This can't be 1. No 5 here. So this has to be 1 or 2, which means this is 3. So this is 1 here, and this is 1 here. So this has to be 1. Seems okay. This 2 still could be there. Yeah, this one looks like it could be 5. It's 1, 2, or 1, 3, and it's with. And this has to be 1. Okay. Yeah, this seems fine. Hmm. If the 7 goes down to a 5, Actually, I guess it still would have 5 degrees of freedom. It's just that you can't use the maximum. You can't use the maximum degrees of freedom to fill out the arrows. You could drop degrees of freedom if we did 5. We have now 3 left, and 2 of them are used from 4 going up to a 6. So there's still 1 degree of freedom left. So that makes the 6 could go to a 7, which seems reasonable. The 3 could go to a 4. Yeah, that seems fine. So this can't be 5 either. And why can't that be 5? Because that would cause one of these to be 4, 5. Therefore, that makes that 9. And therefore, you would need 4 and 5. Right, so if this is 5, say this is 5, right? This we know has to be 1, 2, which means this is 1, 2, or 3, which means this has to be 4, 5, which makes that a 9. So 5 eliminates 5 from here. 9 makes this not 9. This is 4 and 5. So these can't be 4 and 5. This can't be 5. Therefore, the 5 has to be in the opposite corner. The 4 has to be with it. Which leaves 1, 2, 3, 6, 7. But the problem is the 9 is no longer possible. So therefore, the 7 never works. Because the 1 has to be here, right? So therefore, that's the reasoning why that doesn't work. 5 there. Let's see. Can you ever have 4, 5? Huh, I'm not sure. So say you did have 4, 5 there. Therefore, this is not. 4 has to be here now, which means this can't be 4, 5. This can't be 4. This can't be 9. This can't be 9. This can't be 9. This can't be 9. So 4 is one of these two, which means this is at least 1, 2, 3, 5, 6. And it could be 7. Right? So this can never be 6 anymore. 1 snow would be 1, 6, and 1. That's possible. One of these would have to be 6 or 7. Right? One of them can't be, well, no. So this, not sure if we're limiting things. Ah, shit. Got to plug in my mic. There's my mic. Okay. Anyways, this is kind of scuffed because this is going to be a very long one. Uh, can this be 5? Is one question we should be asking. So then this would be 1 through 4. This would obviously not be 5. No 5, no 5, no 5. No 5 here, no 5 here. This could be 5. So if this is 1, 4, this would be 2, 3 in the rest of it. If this is 2, 3, this is 1. So this can never be 1 then. So it still could be 2, 6, and 1 there. That's possible. We lost 2 degrees of freedom, so we have 1 more to play with. This has to be 5 or 6. Therefore, it cannot be 4 with it. So 4 is out. And it must be 2 and 3 with it. Because 1 is no longer available. Because if it's 2, 3, this is 1. Therefore, that can't be. So this is 2 or 3 with it. Because 4 cannot go with this. Therefore, this is 1, 4. So this can't be 1, 4. This can't be 1. This is 2 or 3 with 5 or 6. 2 with 5 would mean it's 2 at most here. This could be 2 and 3. We don't know. So this cannot be, this could be 4. So this is 2 or 3 with 5 or 6. So that means at minimum it's 7 here, which means at minimum this is 8, 9. So far it's looking okay. Hmm. 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 I don't know if this is the route to go down because I don't know if that makes sense. One thing I was thinking of is what was I thinking of? Actually, I don't remember. Huh. Let's see. Hmm. 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 One, two, three, four. What if I remove all the coloring? So where can 9 be? 9 could obviously be all of these. 9 could be either of these two and this one. So this one is useless to me. 9 could be here, here, or here. 9 could be here, 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 or here. 9 could be obviously these. 8. 9 could be here, 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 and here. 9 could be any of these. 7 can be any of these 5, or then that one. Oh, this could be, yeah, well, we already knew that. Hmm. Hmm. We have two rows here with 4, and they're the same columns. But if we try to add another 4, that adds 2 columns, right? It adds this one and it adds this one. If we try to add a 5, that would add 1. No, it adds 3 columns. Hmm. Yeah, that's still good. Never mind. That's not a good path to go down. Huh. We tried 4, 5. That doesn't work. And it doesn't seem to do anything. Hmm. 1, 2. Hmm. One thing I was thinking of is what if this is one of the 1, 2, or 3s here, right? If this is one of the 1, 2, or 3s, that means this is 1, 2, and 3, which would mean this would have to be the other 2 from 1, 2, or 3 that are here, right? But that doesn't really tell us very much, right? You could have 2, 3 here, and this is 1, 2, 3, and then this would be 2, 3. Then you would know this is 6 plus 5 plus 5, so that adds up to 16, but that doesn't limit anything. I guess it makes it so that it um can't be 6. Yeah, but that's not telling us much. Um, can't be 5 or 6 because it'd have to be at least 7, 9. And it can't be 8, 8 in that instance. So it would have to specifically be 7 and 9, and therefore this would have to be 2 less, which means this is 2 and this is 1, 3. So that'd be 2, 3. This would be 9. That's 2, 3. This would be 7. That seems fine. If it's 1, 1 and 2, this could be 1 and 2. Then it would add up to 12. So this would still be 2, and this would be 1, 3. Oh, so that's actually a good question then. Right, because then these two cannot add up to what these two are. So if this is from 1, 2, or 3, and this is from 1, 2, or 3. So we tried 1, 2, 3. This would have to be 2 and 1, 3, and then this would be 1, 2. Or 2, 3, sorry. So then this would have to be 9, and this would have to be 7. If this is 1, 3, this is also 1, 3. So that's 4 plus 4, which is 8. Plus this, which means this would be 2, this would be 1, 3, so this would be 8. This would be 6. And that seems fine. And if it's 1, 2 is the repeat, this is 1, 2, this is 1, 2. Therefore, these would be 6 total, and this would be 12 added together. So this would have to be 7, and that's 5, and this would still be 2 and 1, 3. So that's if you have 2 from 1, 2, and 3 here. We know we at least have 1, but we don't know if we have 2. It could also have a 4 and a 5 there, which, makes things different. Hmm. These two added together is 17 at most. Huh. If these combined add up to 17, that means these add up to 31 minus 17, which is 14. Is that right? 14 at most. I don't know if that tells us anything. Oh, wait, it would be 16 at most, right? 30, no, wait. No. These add up to 17. These add up to, yeah, 16 at most. Because these add up to 30 combined, at least. This could be 3, so it's 33. 33 minus 17 would be 16. Wait, that's not how we want to do it, do we? If this is 17, that's the most. What's the least this could be is the question, right? The least this could be is 14. Um, So if this adds up to 9, if this adds up to 9, that means this could not add up to 9, and therefore would have to have one from 1 through 3. This has to have one from 1 through 3, because it can never be 4, 5. So this would be 1 from 1 through 3, this would be 1 from 1 through 3, this would be 1 from 1 through 3. So the rest would be 4 through 9, which is fine. Hmm. 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 Yeah, that just tells us that it would be 4 through 9 here, 4 through 9 here, 4 through 9 here, 4 through 9 here. That doesn't tell us very much, unfortunately. Um, hmm. What happens if this is 5? If this is 5, this has to be 1 with 2 or 3. So it could be 8 or 9. This can't be 1. So obviously can't be 5 anymore. This can't be 5. We have 1, 2, 3 here, which forces this to be 4, 5, which makes this 9. So that's fine. This can't be 5. This can't be 5. This can't be 1. So this is at least 2 and 6. This would have to be 1, 2, 3, 4, 5, which means 4 cannot be here. 5 cannot be here. Therefore, this would be 5. This would be 4. And we would have the same problem here, right? Because this would be 2 and 6 at most. And we need a 7 somewhere here, which is not possible. Oh, that's an interesting thought I just had. So this is probably the same, right? If this is 5, this becomes 1 and 3 or 1 and 2. Which means this is 1, 2, or 3. You have 1, 2, 3 here. Therefore, this would have to be 4, 5. Therefore, it would be 9. Hmm. I was thinking, what happens if you have a 4 here and a 5 here? I guess that just means that you just lose 2 degrees of freedom. Or 3 degrees of freedom, right? 2 from the 4 going to a 6 and 1 from the 5 going to a 6. So that doesn't actually help too much either. Hmm. Now that's interesting. So, okay. Say this was only 7, 8, and 9. That means you have to have 4, 5, and 6 in the corners, right? If you have 4, 5, and 6 in the corners, the 4 bumps up the 4 bumps up to the 6 to make um, to lose 2 degrees of freedom, the 5 would have to also bump up to a 6 to lose 1 degree of freedom. And then the 6 would have to bump up to a 7 to form another degree of freedom. So that's 4 degrees of freedom that we lose. But if we have the 5 here, then we would lose 2 degrees of freedom. The 4 would also lose 2 degrees of freedom. And the 6 elsewhere would lose 1 degree of freedom. Interesting. Okay. Right. Okay. If this is 5 and 6, that's all 3 degrees of freedom that we lose, right? Because we already have lost a 2 from the 4 going up to 6 in either these 5 or these 5. And then we lose the 7 dropping down to a 5 and a 6. So that's 1 degree of freedom from dropping 7 to 6 and 2 degrees of freedom from dropping 7 to 5. Therefore, that's all 5 degrees of freedom lost. Therefore, these would have to be 1, 2, and 3 if that's the case. However, if this is not, say only one of these is 5 or 6, say this becomes 6, right? We lose 1 degree of freedom from the 7 going to the 6, so that's 1 already lost. The 4 bumping up to a 5, right, the 4 bumping up to a 6 means that's 2 degrees of freedom, so that's 3 degrees of freedom lost. The 5 going up to a 6 means that's also another degree of freedom lost. So it's 4 degrees of freedom lost, which means you cannot have a 5 here in any of these spots because you cannot jump the 3 to a 5 because we don't have 2 degrees of freedom anymore. In addition, so that was if this is only 6, what about if it's 5? If it's 5 that drops down to 2, it's the same thing, right? You lose 2 degrees of freedom from dropping from the 7 to the 5. You already lost 2 from the 4 going up to the 6. Therefore, the 5 cannot be in any of these spaces because you can't jump the 3 to a 5. If neither of these are 5 or 6, that means you have 4, 5, and 6 in the corners, which means the 4 has to bump up to a 6 at least, so that's 2 degrees of freedom lost. The 5 has to either go to a 6 or a 7, which means that's 1 or 2 degrees of freedom lost. I guess the 6 doesn't have to, though. Well, one thing you know, though, is that you can't have 7, 8, 9, 7, 8, 9, 7, 8, 9. But you could still have one. You could have 1, 2, 5 still. Because you lose 2 degrees of... Okay, so... this was... So 4... Hold up. Yeah, so say then you would have either 4 by itself with 5 and 6. So therefore, the 4 would have to go up to a 6. So 1, 2, 3, 5, 6. So we lose 2 degrees of freedom. And then you have 5 and 6 together, which means that the 5 would have to go up to a 7. So that's 2 degrees of freedom again. So that's 4 degrees of freedom there that we lost. Therefore, the 5 cannot be in any of these columns because the 3 can't go up to the 5 again. If you have 4 and 6 together, that means the 4 goes up to a 7. So that's 3 degrees of freedom lost. And you have a 5 in the other row. That means the 5 would have to go up to 6. So that's 4 degrees of freedom lost again. So therefore, you can't have the 5 in columns 4 or 6. And if you have the 4 by itself and then the 5 and 6 together, the 4 is going up to a 6 again, and the 5 has to go up to a 7 because it can't be 6 and it can't be 5. So that's 2 degrees of freedom and 2 degrees of freedom. That's 4 degrees of freedom. Therefore, yes, this you can only have 1 degree of freedom at most in the column 4 red boxes and the column 6 red boxes. Because just of the way this works out. Therefore, this has to be 3 through 9. This has to be 3 through 9. That can't be 9, obviously. This could be 1 through 6. So we know this combination is either 1, 2, 3 or 1, 2, 4. We don't know which. Hmm. Can this ever be 6? I don't think this can be 6. If this is 6, this has to be 1 and 2, and 1 and 2, and this is 3, which would make this 1 and 2, because there's no other place for 1 and 2. But the where's, so then this would have to be 6 also. But the problem is, where can the 6 be in column 5? So this can never be 6. This yellow one can never be 6. It has to be 7, 8, or 9. And if it's the same, if this is not a 4, that means these have to be the same, and then this has to be 2, and then this has to be 1, 3. Right? So we've lowered our degrees of freedom for these then also. So also, I don't think we can ever have a 1. We can never have a 1, 8 in any of these boxes. Right? Because if this becomes 1, 8, that means this is 9. We've jumped from 4 to 8, so that's 4 degrees of freedom, at least, that we've lost. But then if this becomes... Okay, so then... Say this was a 5 and a 6 here. I guess, actually, no, it could be 1, 8, maybe? Let's see. This can no longer be 1. Obviously, this can't be 1. This can't be 1. There can't be an 8 here. There can't be a 9 here. There's no 9 here. This can't be 9. This can't be 9. So this is at least 2 and 3. 1, that works. And this is at least 2 and 3. Oh, wait. Can't be 2 and 3. So this is 2 or 4 at least. So this can't be 6, which means this can't be 4. This is 2 or 3. This is 2 or 3. With 4 or 5. Let's say this was the 4. If this was the 4, we would lose 2 degrees of freedom, and we've already lost 3. So this cannot be 4 here. So therefore, this has to be 4, which means this can't be 4. So that's possible. Maybe? We've lost 3 degrees of freedom, so therefore this must be 1, 2, 3, and 4 combining with 5 or 6. So one of these is 5 or 6 at most. We know the 4 is here. We have 1 of 5, 6, or 7. This is 1 of 5 or 6. So this can no longer be 3. So this is 1 or 2. This has to have a 1. Um, so this is at least 3 or 4. That's fine. This can't be 8. Sorry, this can't be 9. You could have 1, 4, 3 still. That's fine. Hmm. It could be 2, 2, 4 also. This is at least 2, 5, and 1, so this has to be 8 or 9. Uh, this could be 2, 4, and 1, so this can't be 6. This is at least any of those still work. This can't be 1 and 2, so this is at least 1 and 3, but we already know that's 7, 8, or 9. This is 2 or 3, this is 2 or 3. Hmm. If this is 5, this is 1, 4, this is 2 or 3, this is 2 or 3 with 5 or 6. Seems reasonable. Yeah, maybe 1 and 8 is okay. Hmm. Uh, Interesting. So yeah, well, okay, we already knew that. Yeah, the only way this can be 5 is if this is 7, right? And then this becomes 2, and this is 1, 3. Because we know then 2 out of 1, 2, and 3 have to be here. So therefore, that's 2. This has to be 1, 3. And this is the other. So this would be 1, 2, 2, 1, 3, and 1, 2. But that doesn't tell us very much. Um, hmm. Is there any relationship between these two? Not really. Hmm. 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 Uh. So we narrowed it down to 1, 2, 3, and 1, 2, 4 up here. 1, 2, 3, and 1, 2, 4 up here, but this could still be open-ended. Could be 1, 8, could be 2, 7, could be 1, 7. It's a lot of variety. Hmm. I think I'm gonna stop here, and start this up again on another day because it's getting kind of late. So, and I have other things that I need to do right now. Yeah. If I do continue this, you'll see the second part. I'll probably try to post them both on the same day, but no guarantees. Actually, probably, yeah, it makes sense to have both of them up at the same time. Um, if not, then, well, yeah. Anyways, I hope this was enjoyable a little bit, so watching me struggle through the very hard puzzle. Um, we'll see if we can get to the second part and finish this. Anyways, thank you for joining us, and hopefully there will be a second part for this, where you'll see me finish off this puzzle. Anyways, I'll see you next time on Frank Puzzles. Take care.